Welcome to everybody. Today I present StudyBuddy. Now that we have generative AI, universities and schools face a dilemma. Teachers cannot be sure who wrote this essay, the AI or the student. Many teachers come up with a simple solution. They prefer closed book exams and oral exams. Students are challenged more than ever. Meet William. He is an undergraduate student in AI at a university near you. And he wonders, how can I best prepare for an oral or a closed book exam? This is where StudyBuddy comes in. It helps students prepare specifically for closed book and oral exams. Let us look at the methodology. Let us start with the exam training session. William wants to study Chapter 1 of his information retrieval textbook. He uploads it to StudyBuddy. The document is pre-processed in 2 steps. In step 1, the document is broken into small chunks, and with a fine-tuned embedding model, each chunk is transformed into a vector and loaded into a vector database. In step 2, the same document is used to extract a list of topics using a chat model. The exam training begins. The first topic is selected. Based on it, a question and an answer are generated with retrieval augmented generation. Let's have a closer look at this. The vector is transformed, the topic is transformed to a vector. This vector is used to search in a vector store for chunks which are semantically close to the topic. These chunks are fed into a prompt that is passed to the chat model. It generates a question and the ideal answer to that question. This question is then passed to William, who reflects on it. He writes his own answer and passes it to StudyBuddy. StudyBuddy then generates a grade for William's answer and sends it to William, who thinks about it. He then hits the next button. The next topic is selected, and this goes on and on until William feels prepared or tired. In order to teach StudyBuddy a specific vocabulary, I fine-tuned a model. I decided to tune for the field of information retrieval. The book AI-Powered Search by Trey Granger contains the vocabulary of both modern and classical information retrieval. I uploaded it to Google Colab, built a test and a training set, generated question-answer pairs. Then I downloaded a good embedding model, and these were the ingredients for fine-tuning with Llama Index. I pushed the fine-tuned model back to Hugging Face. Let's go to the demo. For the demo, we use 4 pages from the chapter Ranking and Context-Based Relevance. When we first open StudyBuddy, it asks us to upload a document. I have already done this, so we do not have to wait for the pre-training, for the preparation. A topic has already been chosen, importance of ranking and context-based relevance in information retrieval. And from this topic, a question has been generated. Explain the significance of ranking and content-based relevance in the field of information retrieval. Here I just paste a random answer. It's not the answer to this question. And I submit this answer. Now the model evaluates it and finds that it merits grade 3.1 out of 10. We can look at the explanation of this grade. We see the question again, our answer, and the baseline for grading, which is the ideal question, the ideal answer the model has generated before. For grading, the model computes correctness. How correct was the answer? It was correct 3 out of 10. Clarity, how clear was the answer? It was clear 6 out of 10. and the relatedness. How related was the answer to the original query in the response, and it was 4 out of 10. It was just a random answer. The final grade is computed with this formula. And here we see the explanation the model gives for this grading. Now we let it generate the next question. The next topic is selected, the next answer is generated, and the next question is generated, and I just copy-paste this one in the answer field and submit it. Of course, it merits a horrible grade, and let's see why. It isn't clear at all, it isn't correct at all, and it isn't related at all. And here we have the explanation for it. So we could go on and on, but we head back to our presentation and have some code insight. We look at the topic extraction. It is done with long chains load summarize chain. It first creates a summary. And in a second step, this summary then is fed into a special prompt. And with the help of the chat model, a list of topics is being generated. This summarization chain, MapReduce summarization chain, is well suited for big documents too. The document is split into chunks. The chunks are being summarized. Summaries are put together into new chunks, which are summarized again, and this is repeated until we have the final summary. This summary is very dense and contains the most important keywords. We put it into a well-crafted prompt and hand it over to the chat model, which generates a result, a list of topics. Here an example. We take 4 pages of our demo. It generates this summary, and from this summary, it generates this topic list. These are the tools I juggled with. I did not use all of them for the final version. I fine-tuned with Llama Index. StudyBuddy itself is based on LangChain. As vector store, I used Vice. I also wanted to explore what it means to write a productive LLM web application. So I decided to use Flask instead of Chainlit, which is meant for rapid prototyping. What did I learn? How does a productive architecture look like? In a productive system, which works for many concurrent sessions, we would run our Flask application in a web server. Use an external state store, a persistent vector store, and a model server to serve our fine-tuned models. For the demo, I used a much more modest setting, just my local computer with 1 user. Let us come to the conclusion. There are still open issues. It only generates advanced questions. We need also easy questions. Maybe we could introduce levels from beginner to advanced. It is quite impossible to reach 10 points. The grading formula should be reviewed. The pre-processing must be enhanced to handle any form of documents, not just the ones I tested with. And for training of oral exams, we could introduce conversational training style. And last but not least, we need a proper system architecture. However, the proof of concept has been fully successful. It is possible to generate reasonable questions. It is possible to generate reasonable grades and explanations for the grades. And moreover, there are other use cases. Here just an example. Thanks to StudyBuddy, HRs of companies streamline the onboarding process of new employees who have to familiarize themselves with documents and regulations. That's it from me. Thank you for watching.